Okay, now this video is the second video in my transformations of functions videos. And what we're going to look at here are two particular transformations. So I want you to be able to solve problems that involve the transformations y equals a times a function of x and y equals a function of a times x. So in one case the a is going to multiply before the function and one's going to multiply after the function. The impact that this will have on the graphs is also something that you need to understand and be able to get out of this video in order to be able to solve problems that involve it. So the first key concept that I'm going to go through is what happens if we multiply a function of x by a after the function has taken place. And to demonstrate this, I'm going to use the function sine x. And so I've got here the graph of y equals sine x in green. And what I'm going to do is that green one's going to stay there. And as I animate the value of a, as I increase it and even decrease it slightly, you'll see another graph appear as a result of those different values, and that will help you to see the impact that it has. So as we play this video, I'm going to first of all increase the value of a, and what you'll notice is this is how the graph changes. So when a is at 2, this graph has stretched vertically about the x-axis. So the x-axis is sort of like a fixed point. Anything above the x-axis has been stretched vertically upwards. So you can see that it goes now as high as 2 at its maximum point, and anything below the x-axis has been stretched vertically but in a downwards direction towards -2 at its lowest point. And this is something which is very important about this graph. It affects what is generally called the amplitude. And so as I go through and demonstrate this and choose different values of a, as it gets larger, the graph becomes more stretched. Now, one thing I also did in this video was I also looked at what happens if a was, say, a half. And what this does is it is actually halving the values on the y-axis and bringing the graph closer to the x-axis. So eventually, as a gets closer to 0, this graph will get very close to being the x-axis. Now, the general way of describing this type of transformation is to say that it's a stretch parallel to the y-axis, so it's happening vertically, and it's of a scale factor of a. So whatever our y coordinates are going to be, they are going to get multiplied by a factor of a to create our new coordinates for our transformation graph. Now, rather than go on to the next one, I'm going to give you here an example GCSE question. And if you watch my previous video, you can see we've just got a sketch of a function and we're told what the maximum point is. And we're asked to write down the coordinates when the equation is y equals 2 f of x. So because that 2 is outside the bracket, outside the function, it will happen afterwards. The solution to this is to take our coordinate and we're going to multiply that y coordinate by 2 because it's going to stretch that graph vertically. And where it is in this graph, it's going to go upwards by a factor of 2. Meaning that the new coordinate would be 2, 6, and this would get us our mark in this problem. So the second key concept is what happens if the a is multiplying x before the function takes place. Now this one is going to be much harder to explain, but we'll give it a go. And if you've been looking at the mastery statements to the right, it has flipped up to mastering in my opinion. This is a much harder concept to get and to be able to understand. So similarly, this time I've got a red graph, that will stay there all the time, and as I change the values of a, you'll then see the impact that it has on the graph. So first of all, a is going to be increased, and I'm going to try and pause this when a is 2, so that you can see how the graph has changed. So this graph now has been sort of squished, it's sort of been brought closer to the y-axis, it's been pushed in a bit. It's a bit like a spring that sort of was stretched out and it's now being sort of pushed back together again. And so that is how our value of a affects the graph. So it's actually making it go, in this case, oscillate more. But the actual effect is to condense that graph, to shrink it down and bring it closer to the y-axis. And if we continue this, you can see that I'm indicating that it's going to go up and down twice in the same space where it actually did that once. Now, as we increase the value of a, and you can see that it is going now up to 5, this graph, this green graph, our new transformed function, is going up and down 5 times more than it did before. before in the same space. And so this is the impact that A has. Now the video does carry on also to show what happens if we actually had, like before, A a half. So bringing it back to the start, we're now going to have that A is going to be reduced to a half, and this is the change it's had to the graph. Now this time it's kind of stretched it outwards. It's gone stretched it to the left and to the right using the y-axis as a sort of pivot point or a fixed point, and so that graph has been pulled. Again, like a spring, just been pulled out and further across. So for different values of x now, you'd get the same values of y, and this is the impact of this graph. Now it is a tougher type of graph to get, and the description for this graph of technically what's happening is it's a stretch parallel to the x-axis of scale factor 1 over a. So it's not the same as before, and if you think about it, in the previous example when a was a positive value like 2 or 3, the graph would be shrunk down and it will happen 2 or 3 times in the same space. It was doing the same sort of movement, this up and down movement, but in half or a third of the space. Now, there aren't many GCSE questions on this that I could find, but this is one example that matches most of the others, where very similarly, and I've used this before, but this was a later part, what would happen if we wanted the function of half x and that this was happening before the function. So, like before, looking at our coordinate, this is going to have a stretch of 1 over a. Now a is a half in this, so it's 1 over a half, which means our factor is 2. It's actually, if you remember from the last slide I was going through, it's actually going to stretch the graph away from the y-axis. It's going to pull it to the right in this case. And so what's going to happen is in our coordinate, the x coordinate is going to double, because its scale factor of 1 over a is 2. And so because it's going to stretch the graph further to the right, its new point is going to be 6, 1. And this is a much more challenging concept. You may find questions in exercise books which are a bit different, and that if the value in front of x was a number greater than 1, then you'll actually start to see a slightly different effect in that the x coordinate will be reduced, it will get smaller, and that the graph would move closer to the y-axis. But it is a tough concept, and I hope this video has helped with some of the ideas, but do keep plugging away at it if indeed you're finding this difficult. Thanks for listening and watching, and if there's any comments, please leave them down below. Thank you.